I really want this to be taller so it can look down on the dirt and not just be next to it.
Oh, I thought you were going to.
Okay, so, all right, and I will try and do as good as I can for you guys as well. All right, so I made, while we were waiting for this to come back up, blue sand. I think you guys can see it's really bright blue now. And I'm going to mix it in, the dirt.
You should have bought bright blue sand at Dollar Tree. It's sea salt too. I know that's
okay.
sand.
So I got, oops, some of it's not blue.
Oh my
all right,
God.
and I'm going to mix it around because in real life it's dirt just sitting on top, or salt just sitting on top of the dirt.
No.
Do we necessarily see it? No.
No, you have to dig for it.
So I'm going to mix it all in just like it is in real life. Salt and other minerals, like you guys pointed out, salt is a mineral. There are lots of other nutrients and minerals that we know are in the grass, in the ground. Why are all these nutrients and things in the ground?
Because it's earth.
Why?
Because if we didn't have them,
Where did some of those nutrients come from?
dead animals.
The dead animals that were decomposing. All right.
Poop
good.
and pee. Don't do that. I turd. I don't.
Okay. So now I've got water, and it's going to
No.
rain.
Don't do it.
And if this works, then the runoff should the water be clear?
No.
No, it's gonna be blue. It'll be blue.
Yeah, it'll be mud.
It'll be
Ooh,
blue. See, it's blue water.
ooh.
Blue.
All right, you guys can come up and look. The water started to, or the,
See, it's
the dirt
blue water.
moved, but the water was clear when I began. And now the water, hang on. Okay, hang on. Where'd my spoon go? Is my spoon over there?
No.
Hang on. I wanted to see the dirt is moving, and I don't really want to get my hand. All right, you guys back up.
I'll get my hand in there.
Max, do I have a spoon over there?
I'll put my
I'll
hand
back
in.
here.
I just want to touch it.
Yeah.
You may not move. All right, go back to your desks. Hang on a second. Or just take 5 steps back.
1, 2, 3,
Okay, thank you.
4, 5.
Okay, I wanted you guys to see that the water run off. Let me get my dirt. Oh, the dirt doesn't want to move.
Oop.
Okay, you guys see the little bits when I move the dirt?
Whoa.
That the water is super
Where's the salt go?
bright blue. I don't know if you guys can tell.
The water dissolves the salt. I can see the
Can we
salt.
tell? I don't know if you can tell, but yeah, that water in the pan is like
Really?
really bright blue
No, that's
when it
you
runs
said-
off.
You were the one that thought that it would turn to mud. I was the one that thought. I said it was turned into blue.
Yeah, so all that water in there is very, very hard for you to see, but it is super bright blue.
On my screen, we can see it. It's
All right,
really
yeah,
bright
you guys
blue
can
on
tell.
this.
Okay. All right, so why? Have a seat. Have a seat.
I can see it. Sean, why did you? You can see right there.
I know,
Okay.
but then people would just go.
Do we need to argue? No, we do not need to argue. Okay. Now, when the water ran to the other side of the pan, did it kind of start clear, or was it like immediately blue? It was like immediately blue. So if you're looking at the back of your worksheet, for you guys, it's page 4 of, I'm showing it to this camera, and that camera is not the camera that's working right now. You guys, page 4 of Seesaw, the back of your worksheet, it says, how does this model, I'm looking at question number 8, because it says, number 7 is, how does the water compare to the salt? They were the same, right? The color water was the same as the bright blue salt. But number 8, how does this model resemble what happens as fresh water flows to the ocean? So it's fresh water raining down, or even rivers or streams, and then it's going into the ocean. What is happening to the fresh water as it's going to the ocean? Maggie.
It's starting to turn into like salt water.
It's
It's mixing, and it's turning into salt water.
sea salt water.
It's pulling nutrients, minerals, salt from the ground that it's flowing past and through, and it's pulling that salt with it into the ocean. Okay.
Miss Beth,
Are some, yeah, Sophie,
you don't use
give it to me. Why do you think that this is okay?
You just typed in something wrong. So you deleted it.
That's fine. I can do search history.
It's ABC.
Why? We'll talk later because I'm not wasting anybody's time because you can't do your job. Okay, guys. So the question I really want you guys to think about, it says, are some oceans saltier than others?
Yeah, that could be.
Could be. Why would some
But
be?
all water-
Whoa, not all at once.
The Dead Sea.
Zeke is yelling something called the Dead Sea.
The Dead Sea has so
Top-
much salt.
You can come with me today. Hi, let's go listen to Zeke.
So the salt. So I've heard of the Dead Sea, and the Dead Sea is called the Dead Sea because there's so much salt and it like kills the fish.
There's so much salt in the Dead Sea that it kills all the fish.
Yeah.
He is right. This is true.
Search it.
So why would areas like the Dead Sea and why would some oceans potentially be more salty than other? Grayson, why do you think some oceans might be more salty than others?
Because they could have more rivers flowing into them.
More rivers flowing into
Or
them?
they could have a river that connects to like a bunch of other rivers, and then it basically
Okay.
makes more other stuff.
But if they have more, hang on, I'm going to be devil's advocate here, meaning I'm going to argue with you on purpose. Not to be mean, but just to help you guys think. Okay? If there are more rivers, aren't rivers freshwater?
Yeah,
So
but
if there's more rivers flowing into them, they'd be getting more fresh water.
No, but they pick up more salt from the ground. And
They're picking up more salt from the ground, okay?
If the rivers are salty, are freshwater.
There's a lot of people talking at
saltier
once.
Pathways.
Fiona,
How if the fresh water? How would it not be picking up salt if it is touching the ground? How would it not be picking up salt?
how would it not be? So how are the rivers and lakes and stuff not salty also? Ooh.
Because it's also touching the
Ooh.
ground. So
How come the rivers and lakes aren't salty also? Because they're touching the ground, right?
Because they have more like
So-
mud and stuff on the ground.
Wouldn't if more rivers came in, wouldn't it have to share more salt? Like
Okay.
to keep it all salty.
To keep it all salty. Why wouldn't some? Okay. These are all good questions. Any other thoughts? Virtual friends, Josie, what would you like to share?
Maybe to answer Fiona's question, I guess like my first thought was like maybe the minerals will be found in like different places.
Wait, say that again.
To answer Fiona's question, my first thought was that maybe the minerals are found in different places.
Okay. So minerals are in different places. This is supposed to be turned in for a grade, and you're scribbling all over it. Okay. Okay. So maybe. Sorry, are you guys getting like seasick with me moving around? We are going to, Cam. Yes, we're going to discuss that too. All right, Zeke.
Maybe the rivers in the Dead Sea, there's less of them and they have saltier pathways. Or maybe like the ground the rivers travel through that flow into the Dead Sea, they're like the dirt is more rich with the minerals.
Okay.
So, and to answer Fiona's question, it's because the lakes and rivers, well, the lakes and rivers are freshwater, yeah. The lakes and rivers, they're like the ocean doesn't flow into the rivers. The river flows into the ocean. And so the rivers don't like pick up very much salt at all. So it's like its own
I got
thing.
you.
And then the lake, it's closed around. There's nothing flowing into it that's picking up the salt.
Okay. So, all right. I got you. I got you guys. All right. Zeke solved our problems. The first thing Zeke said was, I don't remember.
No, it's
No. I know that, but
The
what was,
soil was more rich in
the soil is more rich in certain areas and has more nutrients, which is why some oceans and like areas like the Dead Sea might be more salty. Now, I'm going to need to bring you along with me to my dry erase board where my markers have disappeared. That's okay, babe. You're fine. I got plenty.
That's okay.
I'm good. All right. Zeke said the reason why fresh water doesn't also get salty, if we think about it, let's see if I can put you guys down for a second. Maybe. And you can see my board, maybe. All right. So if I've got rain coming down, and this is my river, and my river is flowing this direction, right, to the ocean over here. All right. And it's raining.
We can't really see your drawing.
Okay. I'll get closer.
Would it be backwards for them?
It might be. That's okay, though. Hang on. Let me pin and see if I can see what you guys are seeing.
It's going to be backwards on your screen.
Okay, there we go. All right, so this is the rain. And this is my river, and it's flowing this way towards the ocean, okay? So as the rain is falling, guys, can you guys see this? Okay, as the rain is falling, the water is constantly moving this way. So the fresh water is immediately going out here. It's grabbing the salt where it's at and taking it with it. So could a river towards the opening where it turns into the ocean be somewhat salty, like right here? Possibly, maybe. But that water is constantly moving, right? Is it staying still? It's constantly moving. So the river itself is not salty because that water is constantly changing. Does that make sense? And it starts back here as fresh water, and it stays fresh water, and it's picking up more fresh water from rain and other streams that come into it. And it's picking up lots of fresh water. The little bit of salt that it's pulling out is going straight into the ocean. It's not staying in the river because the water's constantly moving. It's just pushing the salt straight into the ocean as opposed to it just staying in this water. The water can't just, the salt isn't going to just stay right here because that water's constantly moving. Does that make sense? And same thing, if I've got a lake or a pond, there's nothing flowing in or out of it. So the salt is all settled at the bottom in the dirt. There's nothing to force the salt to come up and move it around. There's nothing disturbing it. Does that make sense? And the ocean is constantly moving. We know that because of the tides, because of the pull of the moon and gravity. We learned about that, right? So,
Miss Bab, but if the ocean, if it's the
Jason.
river, then if the river's constantly moving and that's why there's no salt in it, if the ocean's constantly moving.
wait, what?
If the ocean,
But the ocean goes in and out, in and out, in and out.
it pulls in.
It's right. It's going. The ocean's got waves that are going back and forth and back and forth. So it's not, the ocean isn't only moving in one direction like a river is. That's the difference. Okay. So also, I can help explain this a little bit. You guys might have to read and do the questions on the article. I really want to move on to the article, but there is, I'll share it tomorrow. There's a mystery, Doug, and it's a really quick one about this, about how come rivers stay freshwater, but the ocean stays saltwater. I want to move on to our hydrosphere article before we get too much further, okay? Because you guys have questions to do with this as well. So we've got an article very similar to all the other ones that we've done, hydrosphere. If you are a virtual kid, you can pull that up and follow along. She doesn't have to do it, but if she wants to follow along, she can. Yeah.
Is that ice?
All right. Because I have my virtual kids are mobile today, I'm going to ask for volunteers to read today. Okay, I can bring them to where you are, and I don't have to repeat it.
Miss Bragg, question really quick.
Yeah, Josie, go for it.
So will we have to answer those questions about the experiment since we just did it?
No, since we talked about it together, you don't have to answer the experiment questions. You just have to worry about the actual like hydrosphere article questions.
Okay.
Okay, just sit down for right now. Don't worry about it. Okay, what is the hydrosphere? Let's start with Kendall, birthday girl.
The hydrosphere is all of the water on Earth. Oceans, lakes, rivers, wells, clouds, fog, and icebergs are all part of the hydrosphere. You may have noticed that Not all of these water sources are in the liquid state. Water vapor and ice are also part of the hydrosphere. Ice is in the hydrosphere as a special name. It is called the cryosphere.
All right, stop right there for a second. So ice, so when we're talking about like Antarctica and the polar ice caps and glaciers and things like that, they're technically water. So they are hydrosphere, but since they're not water that we can use, they have their own special name as well, the cryosphere. All right, Kendall, you can finish up that last little paragraph there.
Our planet is over 75 water, making it appear blue from space. Because of its blue appearance, Earth earned its nickname, the Blue Planet. The
Abundance
abundance of liquid water on Earth differentiates from other planets.
All right, perfect. Thank you, Kendilly.
You're welcome.
All right, let's go. Virtual friend. Does a virtual friend want to read the water cycle? Please participate, virtual friends. Josie, thank you for always participating. I love you lots.
You people, the other people.
We're not saying yucky things. All right, Josie, go for it.
Parts of the Earth's hydrosphere work together to form the water cycle. The water cycle is how water is cycled through the four spheres. Water from Earth's surface evaporates into the atmosphere, forming clouds, or water vapor. The water vapor then cools and condenses, eventually falling back to the Earth's surface as rain or snow. Then the cycle starts all over again. The water cycle is largely responsible for life on Earth.
Awesome. Thanks, Joe. I know you guys know the water cycle because I know we learned this in 3rd grade.
I remember.
And it's probably not the only time you've learned about the water cycle, right? So tomorrow, I was hoping today, I don't know if we're going to get to it today. We're going to talk a little bit more about water cycle in a minute. Virtual friends, please be prepared to actually participate. Josie, I appreciate you volunteering to read. But being on the other end of the camera does not exempt you from participation, okay? I do expect you guys to participate as well. All right. Because you guys also still get your grades on, behavior expectations, the SOAR things. So please make sure you're participating and doing your part. All right, Magnadoodle, the ocean.
The ocean accounts for 97% of all water on Earth. What's more, the ocean covers 70% of Earth's surface. The ocean makes life on Earth possible because of its role in the water cycle and the climate. Climate refers to trends in weather conditions in a given area over time. When the sun warms the ocean water, the ocean transfers heat to the atmosphere. The atmosphere then carries this heat around the globe, regulating temperatures. Without the ocean to regulate global temperatures, Earth would be too cold to sustain life.
Perfect. So does that make sense, guys? Because the ocean water gets warm and it's constantly moving, it's bringing that warmth all over the globe, which is super important that the ocean can retain heat because it's 70% of our surface. So if that 70% was cold all the time, we would be a very cold planet. All right, Ezekiel.
Okay, ocean life. The ocean is brimming with life. There are hundreds of thousands of species who call the ocean home. Some of these species are microscopic or too small to be seen, like plankton. On the other hand, the ocean is also home to some massive animals. The blue whale is the largest species to have ever lived on Earth.
Awesome. Thank you. All right. So hydrosphere is also contains biosphere, right? Is what they're talking about. So there are living things in the ocean as well.
And atmosphere, because like the clouds, like the water goes up into the
Right.
clouds.
So, and then we know that the hydrosphere also interacts directly with the atmosphere because that's where weather comes into play, and a large part of the water cycle actually takes place in the atmosphere. Who else wants to read Lily? Phytoplankton.
Although we cannot see the microscopic organisms living in the ocean, they are vital to marine ecosystems. One example of these microscopic organisms is phytoplankton. Phytoplankton is basically a microscopic plant or algae that uses photosynthesis to create food from the sunlight. Many organisms, such as shrimp and fish, feed on phytoplankton. Larger fish, whales, birds, and humans then eat shrimp and fish in this way. Phytoplankton play a large role in sustaining the ocean food web. If you eat seafood, you have eaten phytoplankton.
All right. Yummy phytoplankton. So it's kind of like ocean bacteria, ocean algae. It's like the little bitty stuff that we can't see, but it's the ocean version of it, of life. Okay. Phytoplankton. And photosynthesis is that same process that is used by trees and bushes and plants and flowers on land as well, that converts the sun's energy, the sun's heat, into the energy they can use to make sugar and food. Okay. All right. Our last section. You want to read? All right, Kaitlyn, humans and the ocean.
Human beings have relied on the ocean for resources for the entire existence. Not only does the ocean provide a source of food, but it is also a route for trade and exploration. Today, people still rely on the ocean for travel and food, such as fish and shellfish. Additionally, most of the world's machinery, grains, and oil are carried by ship across the globe.
All right. Thank you, Kaitlyn. Ooh, sorry. All right. I'm totally knocking down water bottles. Okay, guys. So this article went into a little bit about the water cycle, which we will talk and review it tomorrow. You guys are actually going to teach me the water cycle because I know you already know it. So I'm going to let you guys show off your big brains tomorrow. And it also talked a lot about the ocean. So tomorrow we're going to go into more depth on the ocean because I feel confident you know about the water cycle already. So I'll let you guys teach it and review it really quickly. And then we're going to go a little bit more depth in the ocean, like literally in depth. Ha 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 ha. You see what I did there? It's a terrible, bad, like mom joke or something. Like it's awful. All right. So yeah, girls aren't funny. Moms aren't funny. Anyway, yeah. So we're gonna go in depth about the ocean tomorrow. I think it's a funny joke. I'm just gonna keep saying it. We're gonna go in depth about the ocean tomorrow. And today, you guys have the hydrosphere worksheet. That reviews all of this information from today's article. Okay. So just be prepared tomorrow. Try and remember as much as you can about the water cycle. You're going to teach it back to me. Be prepared to draw your own water cycle diagram, even if you're not the one actually presenting. And then we will be in our textbooks learning more about the ocean tomorrow. So go ahead and work on your worksheets. And I will see you guys in a couple hours, an hour or so for writing. All right. Bye, guys.
Bye. I go to the nurse and get a snack. It's bad.
Yes.